All right, in this video, I'm going to be doing a variety of different lab simulations that you are going to be using to complete your portion of the lab, including filling out data tables and answering questions along the way. After each test, you should probably pause, complete your data table, and answer the question as we go on, and then restart the video when you're ready for the next test. To start off, we're just going to test what is the difference between inelastic versus an elastic collision. So here I have two objects. One is moving to the right, the other is sitting still. They have the same mass, and we're just going to look at what happens when they collide inelastically. Okay, versus what happens when it's elastic. So I'm going to reset that. Notice I've changed this to 100% elastic. Same masses, again, one moving, the other sitting still. Okay, so go ahead and pause and answer the first questions, and then when you're ready, restart the video for the next data set. In this test, we're going to be having one moving object with an equal mass. I'm going to add some more data. This is the information you're going to be putting into your data table. You can ignore position, that does not matter. But we are going to be recording the mass, the velocity, and the momentum. And then you'll be asked a couple of questions for each one of these trials. So in the first one, again, they're the same mass. Both of the objects are the same mass. One is sitting still, one is moving, and they're going to be colliding inelastically. Okay, go ahead and record your post-collision data. Again, ignore position, but pay attention to mass, velocity, and momentum. Okay, for my second trial, I'm going to put this back to inelastic. I'm going to change the mass of my first object to 3 kilograms. Again, the object 2 is not going to be moving at all, and it's still going to be 1 kilogram. So this is your pre-collision data. And there is your post-collision data. For our next one, trial number 4, going back to equal masses, but this time I am going to have object 2 is going to be moving with an equal but opposite velocity, so they are going to collide head on. And there's your post. For our next, we're going to once again increase the mass of our first object, and we're going to have them going towards each other. The velocity of this will be 1, and the velocity of this will be -1. Let's see. And they are going towards each other, and that is your post-collision data. For our final inelastic collision, we are going to have equal masses, and they're going to have them going in the same direction. However, object 1 is going to be moving faster than object 2. And there is that data. Okay, now moving on to elastic collisions. Going 100% elastic, and we're going to go through the same process that we did with the other one. So we're going to start with two objects of the same mass. We're going to start with object 1 with a velocity of 1 meter per second, object 2 not moving at all. And let's go ahead and record what happens after this collision. Okay. For our next one, next trial, increasing the mass of object 1. Again, object 2 is staying put, is not moving, and they're going to collide elastically. For the next trial, we're going to have two objects, same mass, colliding one right into the other, so equal and opposite velocities. So they both have a velocity of 1 meter per second, but object 2 is going to the left instead of the right. And doing that again, let's reset this. We'll have a mass of 3 this time on my object 1, but still doing a head-on collision. And then finally, having 2 objects of equal mass, but one object is moving, and they're moving in the same direction, but one object is moving faster than the other. Okay, so those are all of the trials that you are responsible for recording the data for and answering questions for. Hopefully this gives you an idea of what is different between an elastic and an inelastic collision, and also helps you to understand the law of conservation of momentum.